Now here we will see question number 35, which is a theorem which we need to prove. And this theorem is if in two triangles, sides of, so there are two triangles which are given ABC and DE. We need to draw these triangles. Sides of one triangle are proportional to the sides of other triangle. So they are saying that if the sides of all the sides of this triangle are in proportion with all the sides of this triangle, then their corresponding angles are equal. So they will be equal. Then if the sides are in proportion, then the angles will be equal, so that A will be equal to D, B will be equal to E, and C will be equal to F, is what we have to prove. And hence the two triangles are similar. So what is given is that the sides are in proportion. So we can write AB upon DE. This side AB upon this complete side DE is equal to BC upon EF. BC upon EF is equal to AC upon DF is equal to AC upon complete DF. Okay, because they are saying that the sides are in proportion. Okay, they are saying that the sides are in proportion, so we can write it in proportionality form. And then what we have to prove is this next part. Then the corresponding angles are equal. So then the angles of both the triangles should be equal to each other. So then this angle A should be equal to angle D, angle B should be equal to E, angle B should be equal to E, and C should be equal to F, C should be equal to F. And hence we will say that both the triangles are similar to each other. That is what we have to prove here. Then we will do some small construction, because the guys, we need to follow these steps. We have to first write the statement, then we have to write what is given, what we have to prove, and then if we are doing some kind of construction, then we have to write that construction, then we have to go to the proof part. So construction, what a small construction what we'll be doing here is we will draw P and Q on DE and DF. So on side DE and on side DF, we will take 2 points P and Q, and we will take these points in such a way that DP is equal to AB and DQ is equal to AC. In such a way, we will, draw the points. So AB should be equal to DP. We have to keep the length same and mark this point P. And AC should be equal to DQ, and we have to mark this point in such a way, Q point, so that AB is equal to DP and AC is equal to DQ, right? And then what we'll do is we'll join PQ, then we will join this line PQ here. So this is a small construction what we have to do. And then, so now we'll start with the proof part. So what is given is, okay, in the given what we have is we have AB upon DE is equal to AC upon DF, right? So we have written it. So AB upon DE is equal to AC upon DF. Okay, so now we can write it like this also, right? We can say that DP upon DE is equal to DQ upon DF. Now why I'm changing AB to DP and AC to DQ is because in the construction itself we have written that DP is equal to AB and DQ is equal to AC. So if you write AB or if you write DP, it is one and the same, and if you write AC or if you write DQ, it is one and the same. So AB I have replaced to DP and AC I have replaced with DQ. Here we can say that by construction. Okay, then so therefore I can say that PQ is parallel to EF. I can say that PQ is parallel to EF, So I can say that now PQ is parallel to, because if I can say that dP upon dE is equal to, so what I was saying was, if we can say here in this step, if we can say that dP upon dE is equal to dQ upon dF, if both these sides are in proportion, then by using converse of VPT theorem we can say that this side, okay, this side is parallel to this side, okay, by using converse of VPT theorem. So by converse of VPT theorem we can see this point. Now here, now next further what we can do is, then I can also say that angle P is equal to angle E, and I can also say that angle Q is equal to angle F. Now how I can say this particular thing? See here, if these two lines are parallel, then PE and QF will act like an transversal. So we know that if two lines are parallel and if there is a transversal, then angle P, this this angle will be equal to this angle, and this angle will be equal to this angle. With respect, this concept is called as corresponding angles. Corresponding angles. With this concept, we can say that both these angles are equal to each other by this corresponding angles concept. Now next further what we can do is, now here what I will do is, I will say now in triangle DPQ and triangle DEF, I am taking this small triangle DPQ and I am taking the bigger triangle DEF. Okay, so I am taking these two triangles and I'm going to prove them that they are similar. So how I can do that? I can say that angle P is equal to angle E, and I can say that angle Q is equal to angle F. Why I am saying this is because just I have proved it above. Proved above. Right? So now I can say that by angle similarity, okay, criteria, okay, I can say that triangle DPQ is similar to triangle DE. So we have proved that this small triangle and this bigger triangle, they are similar to each other. That is what we have proved here. Okay. Now we will go next further. So on the earlier page, we are continuing on the next page. So on the earlier page, we proved that DPQ is similar to triangle DEF. So this small triangle is similar to the bigger triangle. So now we can write this in similarity form, right? So we will write this in similarity form. We can say that uh, dP upon dE is equal to PQ upon EF is equal to dQ upon dF. So dP upon dE is equal to PQ upon EF. PQ upon EF is equal to dQ upon dF, dQ upon dF. So we have written this in similarity form. Now what we'll do is we will take these two things. Okay. Now we know that, but dP is equal to AB this is what I'm saying is because of construction. So by construction, so instead of dp I can write ab upon d equal to pq, the next thing as it is pq upon ef, and this is by construction. Okay, let me just number this as 1. Then ab upon de is equal to bc upon ef. This we are writing as per given. So you can check by going back to the previous slide that AB upon D is equal to BC upon EF. This is as per the given statement. So let me just write this as 2. And from 1 and 2 now, from 1 and 2, we can say that if this AB upon D is equal to this, and if the same D AB upon D is equal to this, then these two things should also be equal to each other. That is what I will be writing. So PQ upon EF will be then equal to BC upon EF. And both these denominators I will knock off, and then what we will be left off with PQ upon BC. So here what we prove is, so PQ is equal to BC is what we prove here. Now what we'll do is we will now we'll take these two triangles in triangle ABC and triangle DPQ. So this small triangle and this small triangle. Okay, we'll take these two triangles and we'll prove them congruent. Okay, so AB is equal to DP and AC is equal to DQ. Both these things are by construction, because we have made the construction only in such a way that we have kept AB is equal to DP, and AC we have taken the same measurement and we have marked the measurement for DQ. So this is by construction only. And then just now we proved that BC is equal to PQ. So just now proved above earlier. So therefore by SSS congruency rule or criteria, we can say that triangle ABC is congruent to triangle DPQ. Okay, because these are all the sides, right? So this is also a side, this is also a side, this is also a side. So side, side, side congruency rule. So both these triangles are congruent. Then by CPCT, okay, then by CPCT, we can say that angle A is equal to angle D, angle B is equal to angle P, and angle C is equal to angle Q. So A is equal to D, B is equal to P, and C is equal to Q. So this is by CPCT, because once we prove that both the triangles are congruent using CPCT, we can say that the remaining things are equal. So the remaining things are the angles, because all the three sides we have proved already they are equal. So the angles were remaining. So by using CPCT, we can say that even the angles are equal. Now further, now in triangle ABC and triangle DEF. Okay, so ABC, this ABC small triangle and the main triangle DEF. Okay, we'll take these two triangles now. Here I will say that angle A is equal to angle D. Okay, so here only just now above we have proved this. So I will say from above. Okay, then I will say that angle B is equal to angle E, because earlier, okay, we have proved that uh, angle P is equal to angle E. We have proved this earlier. So with this logic, if P is equal to E, okay, if P is equal to E, then so if P is equal to E, then instead of P, here I can say that B is equal to E, because instead of P, I will replace this P with E. So B is equal to E I can write. And similarly, I can write that C is equal to F, because in C is equal to Q, but I will write F because earlier we have proved that angle Q is equal to angle F. So instead of writing Q, I will write F here. Okay. So we have proved this earlier. Okay, on the earlier page you can see. So now we can say that finally we can say that by angle is sufficient, but we have proved all the three angles. So by angle of similarity criteria, we can say that triangle ABC, okay, is similar to triangle DEF. Okay, so here whatever we wanted to prove, in the to prove part, we have proved that A is equal to D, and B is equal to E, and C is equal to F. So here A is equal to D, D is equal to E, and C is equal to F. So all three things we have proved here. Okay. Then we have also proved that both these triangles are similar. So that is what was asked to prove in this theorem. So we have completed and we have proved each and everything. So guys, we have completed the theorem here. Please like, share and subscribe the channel. Thank you so much.